5, SL students, a small point. The first few parts of this question are relevant to you. However, there are some bits which are no longer relevant. Okay, obviously the question number is different as well. However, the content is exactly the same. Okay, here we go. We've got a beam of microwaves. You'll be noticed this as a double slit experiment. And we're experiencing maxima at certain positions. Now, just to be explicit, what I've done here is written down the order of our maxima. So we have n equal to 0, n equal to 1, and n equal to 2 here, w, x, and y, and we know they are separated a nice uniform distance apart. First thing we want to do is explain why intensity maxima are observed at x and y. Well, the reason for this is because constructive interference has occurred. So really, in your answer, you need to express that there is some constructive interference, and then explain why. Well, why there is constructive interference here is because these two waves have traveled different distances. They have a path difference. And as you see on your data booklet, we have constructive interference, which comes with a path difference of n lambda. So really, you are just asked to kind of remember that in your answer, okay, that we have an integer multiple of the wavelength. Okay, in other words, path difference in lambda. This question is one of those ones that students tend to find very hard to answer. However, when you see the stuff that's required, there isn't really very much. It's just simply the idea that we've got constructive interference and then why that constructive interference has happened. Okay, if we then scroll down, we're then told the distance from S1 to Y and S1 to X, S2 to Y, sorry, are those two values there. Now this is where this kind of noting of which order we're looking at is helpful. We're looking at this point here, Y. This is the n equal to 2 part, and so what this means is that at Y, n is equal to 2, and therefore the path difference, PD, is equal to n lambda 2 lambda. And therefore, we have a value of lambda which is 0.031 meters. Okay, now this is again something that I've noticed students sort of have a little bit of trouble identifying there. It's simply the idea that we're looking at 2 lambdas rather than 1 here. If you use 1 lambda, then you will get the wrong answer. How do we get that answer? Well, now that we know the wavelength, we can use our equation, which is in the data booklet, c equal to f lambda, where c is 3 times 10 to the 8. And again, that could be found in the data booklet. If you're not sure, just flick up to our fundamental constants and you'll find it here. 3 times 10 to the 8 divided by 0.031, which is 9.7 times 10 to the 9 hertz. Okay. We then want to understand why the maxima at W, X, and Y will have different intensities from each other. Well, this comes from the fact that our S1 and our S2 behave in the same way that a point source would behave. In other words, the wave from S1 and the wave from S2 is going to have traveled a different distance. As we know that for waves spreading out, the amplitude will decrease with greater distance, and therefore the intensity will decrease too. So if we look at those points W, X, and Y, the waves in each case are going to be traveling different distances, and so therefore they are going to be changing in terms of intensity, and so therefore the intensity maxima that we observe are going to be different. Okay, this is where I think our SL portion finishes. We'll carry on with the HL. 5D, we're looking at the microwaves emitting and looking through a polarizing filter. Okay. As soon as we see polarizing filters, we're going to try and find our Malice's law. Oh, this is still, my apologies, this is still SL. Okay, Malice's law, I equal to I0 cos squared theta. Okay, we're going to rotate our receiver about 180 degrees about the horizontal line passing through the microwave transmitter. So here we'll use Malice's law, I equal to I0 cos squared theta. And really we're interested in the behavior of this cos squared as we rotate. We should be aware that at the beginning we started with cos of 0, and therefore cos of 0 squared is going to be 1. As we rotate to 90 degrees, we're going to go to 0 because cos of 0 is 0, and then that squared again is also 0. And cos of 180, well, cos of 180 is -1. We square it, we've got 1. So why is this important? This is going to show us our variation of intensity that we're going to plot on the next axis. And what you should see here, our rotation angle goes from a maximum down to a minimum at 90 degrees and then up to a maximum value again. Now, key point here being that it never goes below 0. Why? Well, because intensity is a scalar quantity which cannot be negative. So intensity is 0, the maximum intensity can also not be negative. And cos squared, by squaring that, we're also getting a non-zero value. And so therefore, we're looking at this cos squared shape. Okay, in terms of marks for this part, it's a 2-mark question. You're looking for that cos squared shape, which has a 0 value at 90. Okay, so this is really important here. All right, that's the end of question 5. Hope you've enjoyed it.